Thank you all for joining us today for this workshop on data visualizations for the Scholarship of Teaching and Learning, some tips and tricks. My name is Trish. I'm an evaluation and research consultant with the Center for Teaching, Learning and Technology, and I also work with the Institute for the Scholarship of Teaching. And I'm joined by my colleague Natasha, who's a Scholarship of Teaching and Learning facilitator, also working within the CTLT and SoTL. So before we get started on today's session, I just want to take a minute to honor the existence of the first peoples whose lands I'm joining you from today, which are those of the Musqueam people in the area that's known as Vancouver. I'm joining today from the UBC Point Grey campus. And I really appreciate this place that I've had the privilege to live the area I've had the privilege to live in for almost 10 years. I've had the chance to learn so much from the areas that I'm part of and UBC campus, and I hope to continue to learn and grow in this area I call my home. I want to acknowledge that many of you might be joining us from different locations, so just take a moment today to appreciate and consider the lands that you're joining us from.
Great, so I'll just take us through our outline for today's workshop. Please, of course, feel free to throw questions into the chat at any point in time, and then we will have breaks for Q&A as well. So just to go over what we're going to chat about today, so we'll go over the basic principles of data visualization. We'll talk a little bit about why you're visualizing, so what is the purpose of your visualization. We'll go over some basic kind of do's and don'ts. So we'll go through two of the most common types of visualization. So we'll talk for a good chunk of time about bar and column charts, and then we'll talk for quite a while about line plots and scatter plots, and then we'll also touch on some of the less common visualizations that you might be using and what the advantages and disadvantages of each of them are, what kinds of data they're best suited to, and how to kind of best practices for how to make them best. And then we'll talk about best practices overall for visualizations, as well as some considerations for accessibility and ensuring that your visualizations are accessible to everyone. And then we'll end with some Q&A and a list of resources that helped us put together this workshop, and then for you to further pursue on your own as well. So just diving right in, the first kind of before we get started with principles and guidelines, we would really encourage you to think about why you're visualizing your data. So what is the story that you're trying to tell? Remember that as the person who is creating the figure, you are the one who is interpreting the data. You are the one who is responsible for trying to communicate that story to your audience. So the first thing we would encourage you to consider is, who is the audience for your visualization? So is the audience an expert in the field? Are they an expert in the data? Will they know the story that you're trying to tell? And we would encourage you to consider how you could simplify visualizations that you're using so that people with expertise in the field and people who are novices in the field will be able to pull out the information that they need, will be able to understand what the purpose of the visualization is, and then also to simplify to ensure that it's accessible. And so we'll talk about that primarily at the end, like I mentioned, but these considerations are true for all data visualizations, but particularly important when we're thinking with regards to accessibility. And then the second piece to consider is kind of how should the reader benefit from this visualization or this image. So considering how your graph or your visualization might help the user understand insights from the data. So thinking about whether the purpose of it is primarily to kind of provide an overview of the data and allow the reader to learn more and to do their kind of own interpretation, or considering what story is it that the data is telling, which helps you decide what aspects to focus on. So which pieces are important for us to highlight instead of creating kind of an overwhelming visualization. So I really like this quote from Edward Tufte. So Edward Tufte is an American statistician and professor, and I really appreciate this kind of perspective on how to create a good visualization. So essentially, a helpful rule of thumb is, can you understand what is happening in this graph or this visualization in about 5 seconds? So if the visual that you're using is actually adding more complexity to your text, or is taking away from your explanation in some way, think about whether it's actually useful and consider whether you actually need that visualization in the first place. And then I appreciate this kind of perspective of communicating the greatest number of ideas in the shortest amount of time with the least amount of ink. So really thinking about how to streamline how you would best conceptualize what you're trying to get across, and then how to make sure that that's done in the best way possible. So we've created kind of a quick and easy, a lot of our workshop is designed around kind of quick and easy lists and heuristics and tips and tricks to keep it simple when you're trying to think about visualizations. And so kind of we've got 3 points of kind of what a good visualization consists of. So the first point is a pretty straightforward one. You want to make sure that your visualization is representing the data accurately. So you want to make sure that everything is clear, that there aren't any errors, that you've got everything that you need to represent things ethically and accurately. So you're not, blowing the data out of proportion. You're making sure that you really are representing everything accurately. The second point, which is often more challenging, is clearly indicating how the values are related to one another. So how are the different points on your graph? How are the different pieces of your visualization related? And how have you made that clear to the audience? So is it clear to the audience how those different pieces are related to one another? And related to that, the third point is making it obvious how you're meant to use the information in this visualization. So drawing attention to the pieces that are important, making sure that those are highlighted, clearly labeled. And then there's a couple of kind of potential additions depending on what you're trying to do. But those a couple of additional pieces to think about might be making it easy to compare the different quantities depending on what type of data you're working with. And then also considering how you might make it easier for your audience to see the ranked order of values. So looking at what's highest, lowest, how that might be organized in a helpful way for your audience, if that's something that's relevant to the visualization and the data. So I'm going to have us do a quick kind of throw out a quick question for you. The point of this slide and this activity is really to kind of consider, before starting to visualize data for others, the importance of visualizing our data for ourselves. So I've got a quick poll that Trish will just pull up here for us. And I want you to just take a second, take a look at these 4 graphs and think about which graph has the highest mean. So I'll give us about 30 to 60 seconds to answer this question. All right, so these are this is kind of our findings. So I appreciate the person in the chat who has asked if it's a trick question. It is absolutely a trick question. For those of you who indicated more than one of the above for the means, would you mind just throwing into the chat which ones you're thinking of, A and B? More than one sounded like the safest option for what might be a trick question. Great. So I will give us the answer. So actually, these 4 graphs are known as Anscombe's quartet. And all of these figures actually have the same mean. They also have the same standard deviation, same variance, same correlation. So the correlation for all of these figures is about 0.8. And I wanted to highlight, this is kind of a fun thing to think about, but it's also actually a really useful and practical thing to think about. So the importance of visualizing data for ourselves before we're actually creating visualizations for others will help us determine what the pattern of data is, what the distribution is. It will help us look at whether there might be outliers. So for example, in graph D, there isn't actually a relationship here. There's one outlier that is creating this correlation, that's creating this kind of false sense of relationship. It's important to think about outliers and anomalies. It's important to think about how the data is distributed because that will help us find errors in processing. It'll help us find those outliers. It will impact the types of statistical analyses that we do and whether they're actually representing the data. And then they will also help us to consider how to best present that data for our audience. So particularly if you're going to use things like averages or variance correlations or medians for showcasing your data, it's important to consider what the shape of the data and what the distribution of the data actually is, because these values can misrepresent the data when it isn't on a normal distribution. Visualizing the data for yourself will also help you do things like figure out if there's anything missing. So for example, there might be a category where you would expect to see data, but you found no responses, and just kind of better understand the data at large. So we'll move into talking about one of the most common types of figures. So we're going to talk about bar and column charts first. And bar and column charts in general are most useful for comparisons. So they're most useful when we're comparing different categories, when we have categorical data. Trish will talk about what happens when we have data that's more kind of spread on different kinds of scales. But bar and column charts are particularly useful for comparisons, and they're useful for plotting means or ranges of value. So things like Likert scales, grades, different kinds of scales that we might be asking in our SoTL project. So things like motivation, self-efficacy, those kinds of things. So I'm going to have us be involved again a little bit. So we've got a picture of a problematic bar chart. We're going to pull it up here in a second. And I'm going to give us about 2 minutes to look at this chart and just make a list of any concerns. So what are things about this chart that strike you as problematic, that might be an issue for someone trying to pull out data from this chart? And I would encourage you to take a few minutes, type those potential issues into the chat, but don't press enter just yet. So in a couple of minutes, I'll say go, and then we can answer simultaneously and then take a couple of minutes to read through all of the responses. So just take a minute here and look through different aspects of this chart and think about what might strike you as problematic or challenging with this visualization. All right, so you can go ahead and press enter. Perfect. And then we can take a few seconds, maybe 30 seconds to a minute, to just scroll through and take a look at everyone's responses. Great. So we've got quite a few people talking about changes over time are very unclear. The colors are very unhelpful. They're too similar. It's hard to differentiate. There's just way too much information on this graph. You can't actually figure out what information is necessary to pull out. It's hard to look up or search for a particular piece of information. Too much data, doesn't show any kind of relationships. Great. Yeah. So it seems like most people have pointed out kind of common issues. So we'll go through how we might pull out some of the data from this visualization and improve it. And in that process, kind of go through the primary principles, tips, and tricks, how this might be improved. So one way that we might improve this data, so the first way that we might consider making our data clearer is using a subset of the data to tell a particular story, and then ranking those items in a meaningful way. So this version of this graph pulls out just a particular subset of the data to tell a specific story, and it's much more streamlined. It's much clearer here. It's much easier to pull out the information. The colors are much more clear and differentiable. You can tell the colors apart. And one thing to keep in mind in general is kind of best practice. When you are ranking items, consider the most helpful way to rank those items. So with a small number, so here we only have 5 items, it makes the most sense to rank them by count or by percentage, so from least to greatest or vice versa. When you have a much larger number, so for example, if you did want to include more of that information from the previous graph, consider ranking alphabetically and then highlighting what the key pieces are. So we'll talk a little bit about how to highlight on the next slide, but just thinking about how the audience might more intuitively be able to pull out the data that they want, and whether that's best suited to ranking by order of the numerical values or in some other meaningful way. So in some cases, we might not want to remove all of the data, but we do, and we want to show multiple items, but we do want to highlight particular pieces. So here we might use perceptual features, so something like color or perhaps kind of some other form of highlight to highlight what you want the viewer to focus on. So here we might do something to kind of make the data pop a little more. So here all the bars are on the same y-axis, the same dependent variable. So there's not actually a need for all of those different colors. They only add to the distraction instead of streamlining your visualization. By using this labeled axis, you're removing distracting visual features that don't add information, and then you're just using color to highlight where you want the attention to be drawn. So what is the most important thing for people to focus on? We'll also talk a little bit later about how labeling the axis here might actually be a best practice with regards to accessibility. So Trish will touch on that later as well. But considering considering the value of highlighting the pieces that you want your audience to focus on instead of creating a more overwhelming visualization. It's really about how to streamline so that you can get the story that you're trying to get across. And then the third point that we might consider for making data more clear, particularly for a bar or column chart, is sometimes we might have these kind of stacked plots. So if we're looking at different areas or different pieces, or even on a Likert scale, for example, the issue with stacked plots is that they don't always allow for easy comparison across different groups or across different categories. So breaking it up here will provide a much more useful comparison across all of the different categories. So if we look at the figure on the left, when we look at the orange, so the health bar, it's pretty easy to compare. When we get to yellow, it might be possible, but as we get further along, it becomes essentially impossible to compare those different the different countries in this case, whereas on the right, it's much more clear. We can see the trend immediately. It's very obvious where there might be outliers or things that we might be interested in pulling out. And then our final kind of tip or trick for bar and column charts is considering what might happen when you have really long axis labels. So we would encourage you to consider using a column chart instead of a bar chart if the labels are long. So instead of using the columns, we would encourage you to kind of rotate the graph so that the labels run along the y-axis and so that the numerical scales are on the x-axis. And we might also encourage you to consider whether these labels could be shortened. So thinking again about how to streamline best, what is the best way to ensure that your visualization includes the least amount of ink, so exactly what you need for there to be here. So we'll just touch briefly on particularly highlighting Likert scale data or Likert type data. And kind of two tips or tricks that we have for how to best do that. So the first is sorting data from largest to smallest, particularly sorting your strongly agree or your positive or one extreme of your scale, and then sorting your data from largest to smallest. So if we look at the graph on the left and compare it to the graph on the right here, we can see that it's much more easy to figure out kind of what where people have the strongest positive responses, where people have the strongest negative responses at a glance, as opposed to having to sort through the data on the left. So by providing this kind of distribution of the data, you're providing information on all of the resources, all of the responses as well. So I would encourage you to consider how, for Likert scale data in particular, just providing a mean and a standard deviation or a mean and some sort of variability measure may not provide enough information, and providing a distribution is actually a more helpful way to consider doing that. And the second point is, if you are going to use stacked plots for Likert scales, consider using 100% stacked plots so that the data is equally spread and more easy to compare. So if we look at the left versus the right here again, it's much more intuitive to pull out data from this graph on the right. But one thing I would caution you to consider is that if the groups represented in the categories are very unequal, folks in the audience may misinterpret the data and see them as equal. So for example, here, if you have a number of students in person, a number of students online, and your in-person cohort is only 6 or 12 students versus 50 or 100 online, or vice versa, be mindful that representing the data in this way may encourage people to think of them as kind of equal ends or equal samples. And so really highlighting that or considering alternative ways to do that is important as well. And finally, with regards to bar and column charts, we might consider whether they are always the best option. So sometimes if a bar chart is too messy, we might consider two alternatives. So we'll propose these two alternatives for you here. And both of these alternatives can actually be made in Excel, and we have a resource that will help teach you how to do that if that is something that you're interested in. So these are adapted from a book. And so one thing that we might consider is a slope chart. So slope charts are useful for showing change over time, particularly compared to a bar chart. So again, if we compare the left to the right here, it is much clearer on the right-hand side, and particularly if we split that up into kind of those 4 separate graphs, but combine them into a visualization, it becomes really easy to intuitively pull out the data. And then the other alternative that we might consider is a lollipop chart, which helps compare the data more easily. So particularly when you only have two categories of data that you're comparing and you want to see how they're changing over time or over groups, some sort of split, this is a really helpful and streamlined way to visualize that data. So we'll pause here and see if there's any questions, anything we can answer. There's a bit going on in the chat here. Any questions in particular about kind of bar and column charts, best practices for those?
Can you clarify with that line chart over time for different years, the grades one as an example, that data probably wouldn't be considered as continuous, and so should those really be connected as a line chart?
Yeah, a great question. So we will, so we've talked about bar charts as kind of particularly useful for categorical data, whereas line charts are more useful for continuous data, which Trish will touch on in just a second. So yes, there are advantages and disadvantages to both. So ensuring that you're able to kind of highlight those pieces. I mean, there is some value in being, like, we could consider time as kind of a continuous variable. So for example, thank you, Trish, for the kind of grades over time, we could consider time as a continuous enough variable that it would be okay to use that kind of thing. Whereas the grade split, I would not encourage you to use a line chart for the grade split, which is why we suggested the lollipop chart or something like that, because it just shows kind of the 2 points. It doesn't suggest that there's a continuous relationship between those pieces. Yeah, a good question. You always want to be mindful of ensuring that the data is accurately represented, and this is often a common issue with using bar charts for continuous variables and vice versa, using line charts for categorical variables, and that can misrepresent the data absolutely if you're using the wrong type of visualization.
Okay, thanks everyone. So I'm going to take over from here and talk about a few other chart types, and then move into some tips around accessibility and considerations around accessibility. So moving on to line and scatter plots. Again, thinking about the cases where one figure type is better or more useful than another. We typically tend to think about line and scatter plots as being useful for things like temporal data. So looking at things like changes over a term, over years, looking at pre-post data. So where you're trying to kind of say like what's happened as a change over time, as well as for things like continuous data. So looking at something like student grades, where they're on a scale. So some tips and tricks and ways to make your data clearer is reducing clutter. So, and by clutter, we mean things like varying fonts, depth, axis lines. As you can see from the figure displayed here, there's a lot of information. So you could imagine a plot like this for something like grades or motivation over time, or looking at a kind of relationship between those. But it's quite a messy plot. So here, you have to line up which color goes with which line. There are a lot of other lines that are represented there. It might be hard to kind of really look at a clean comparison. So one easy way to clean that would be to just simply move that legend onto the axis itself, so you can more easily tell which line is associated with which. That's a very small, simple change that you can make that would make a huge difference in being able to look at the data. You're not having to jump back and forth between the legend and the figure itself. Another piece when looking at scatter plots is to highlight the focus of the data. So you can think about adding color to a subset of data points or changing the title to emphasize a point. So again, here it's quite an overwhelming figure. There are a lot of colors. You're trying to match the color with the actual data itself. And it can be a little bit overwhelming to process this data. We're here in this alternative figure, pulling out just a subset of the data. So here we're simply looking at European countries, so pulling out a certain category of the data can be helpful to help people see what's happening in that for that relationship itself. Again, you really need to think about what the story is that you're trying to tell. So you can see here, the title has changed. So it's looking at just European countries. But that's what the point of this figure is to highlight that relationship. Depending on what you're looking at, maybe it makes sense if you're doing a comparison. So you would include two of the items, and then you can kind of look at how those relate to the other areas. Something to be mindful of when you're using scatter plots, so these types of figures, is just to be mindful of perceived correlations. So just thinking about the way the data is presented and whether it can make it seem like there might be a relationship that may or may not exist. So that's kind of another conversation to be had, is the type of statistical analyses that you do with your data. We won't get into that conversation here. But just be mindful when you do use a scatter plot, it can often lead people to think that a relationship might be there that isn't. So for example, I don't actually know what the correlation on this figure is, but someone might say, oh, it looks like there's a positive correlation. It seems like there's, this relationship here. So just being mindful when you're presenting that type of data, if you've done that analysis, to report it, or, just to be really clear that there's perhaps a trend in the data. Okay, so a less common visualization, but one that we still see quite commonly, are pie charts. And we're just going to do another quick poll here. Oh, thank you, Natasha. So just I'll give everyone about 30 seconds to answer this poll. Which area you think is the biggest from this pie chart? Adam, I appreciate your skepticism. With data, you always want to have a healthy amount of skepticism. So I appreciate you bringing that to today's session. So what we can see here is a lot of people voted for number one. We do have some other responses in that areas 3, 4, or 5 are the largest. Some concerns in the chat that maybe they're all the same, or none of these answers are really really the right one. So what you can see here is that we've taken the data and just simply moved it to a bar chart to really highlight the closeness of the data. So how similar some of them are, but how different some of them are as well. So it can be really hard with pie charts to tell the difference in areas. I strongly recommend against using pie charts. There's rarely a case that the data presented couldn't be presented in another way. So this is just a very simple adaptation of the data in this bar chart here. But it really highlights that, for areas 1 and 5, they're really, really close. And when it's simply presented, as it is, without something like a percentage or a numerical count of how much is in that area, you really don't have enough information to be able to make those comparisons accurately. And while you could do something like simply add a percentage to the bar chart or a number to indicate what is in that area, bar charts are also just really difficult to process visually. It's much easier to do something like a bar chart. You can also add numerical labels to something like that. The area of a pie chart is confusing to process. It rarely makes sense. So I really beg of you, if you take away one lesson from today's workshop, hopefully you take away more than one, but the number one I would recommend is just please don't use pie charts. It's really misrepresentative of the data, or it is hard for people to process. So building on that a little bit more, basically what I said, it's really hard to compare those slices in the pie charts when it's the value is not included, so it's difficult to interpret. Likewise, looking at something like a bubble plot, which is displayed here, they're just really hard to accurately compare areas. So looking at Nigeria versus the Congo, like those don't look that different to me, but numerically they are quite different. It's just rarely the best way to present your data, especially when you're looking at comparing against other like categories. You're trying to compare the data. This is something that Alan mentioned. I'm pretty sure, yeah, we were talking about the donut chart. This if, someone's like, I need you to make me a pie chart for some reason, that's the request and you really need to accommodate that. These are sometimes called donut hole charts, or I forget the name. Ellen mentioned another one in the chat, the ring chart. So this is another alternative. And it just really helps reduce the issue of the confusing area. So with the pie chart, there's this sort of triangular pie shape, and that makes it really hard to process the numerical value of what's in that area, where something like this donut hole chart or ring chart makes it a lot clearer. As you'll see here, we also included the labels directly on the item, so indicating what the percentage is. It's also organized by size, so you can kind of get a better sense of how the distribution lies, and you can more easily compare those categories. The other thing, or another case in which this would be okay, is when you have a smaller amount of data. So in this one here, there's only 5 categories. If you had more than 5, it really just gets more confusing, and it makes more sense to pull out something like, the largest category or the smallest category, or talk about the data in a more descriptive way, as opposed to trying to compare the values when they're really similar and you have a lot of them to compare. Yeah, just seeing a comment in the chat again around pie charts that it's harder to judge the area, but it's easier to judge circumference. So making a case for the pie versus donut chart. So another visualization that we don't see too often, I think in kind of academia or research, but we do see quite often in things like infographics, and can be really useful depending on the message you're trying to get across, or to kind of simplify information. So pictographs. So an example here is a picture of a person to indicate how many people the data represent. Really want to encourage people to not truncate a person or truncate whatever it might be, a car, a building, tree, whatever the item is you're trying to represent. Always use a full image. So, there's no such thing as half a person. Again, thinking about something like a median instead of an average to represent the data that you have is a better representation. Likewise, don't distort the images. So if you want to say something like 100 people versus 200 people, and you're using a single image to represent 100, don't simply make that person larger. Again, this is an issue around perceiving the area and how much that represents. Is this truly a double of the 100? Instead, if that single image represents 100, use 2 of them to indicate 200. If you're using something just like blocks to represent area, you want to provide a numerical visual of the item. So don't make people count. Very quickly, it would be hard to tell how many are in this block. There's 15, but without that number, it's kind of awkward to have to count each of those squares. So including that number there is really useful if you want to use a visual like that. Another option is to group the data in a way that's easy to tally. So instead of having one block represent 7, so needing people to do a little quick math to figure out how many this is supposed to represent, have a block indicate something like 5 or 10 that's more easily multiplied out. So I can quickly say, on the right, there's 60 blocks, whatever those blocks represent. Okay. And finally, I wanted to share with you a visualization for mixed data presentation. So this is just an example that we came across, and it's not talking about teaching and learning data, but I thought it was a really great example to showcase how you can present data that includes both numerical data and also something like qualitative data, which we won't be getting into in our discussion today, but just to show a way that you could visualize both of these in one figure itself. So looking at a sort of more of a holistic look of the data, including both quotes and something like a figure indicating some Likert scale data is just really kind of a nice overview, and it's a way to combine that qualitative piece to your data that sometimes gets lost. Okay, so next we're going to move on to some best practices. So these are things to consider regardless of the type of figure that you're using. So just things to be mindful of as you're putting together your figures. So when looking at the y-axis, so that's your axis that runs up and down like this, you want to use a scale that doesn't over or under exaggerate the trends or differences. So I'm going to show you 3 different figures that all showcase grade increases over time, but you can see that they all look quite different. So the data is the same, but by simply changing the y-axis, it really impacts the way the data looks. So in the first figure, the data looks quite flat. It's really minimizing the difference. And the scale on the y-axis is 25. Moving into the middle figure, you can see that the differences is quite exaggerated, that it's maximized. So by having the y-axis only on a 5-point scale, you're kind of perhaps over exaggerating what the data is. Out of these 3, I'd say the third one is the best choice, where there's a 10-point difference between each of the y-axis items. You're getting kind of a sense that there's a trend happening there, but it's not necessarily, you can't really make anything of it unless you're doing some kind of statistical analysis. So again, just being really mindful of not overemphasizing trends that exist, especially if you're not doing an analysis to follow up to say whether that trend is meaningful or not. The only other thing I would caution people to be mindful of is in this last scale, the axis isn't starting at 0. Or the y-axis isn't starting at 0. So just be mindful of this because it can skew perceptions of what the data is. So, you're kind of showing that the lower bound here is about 75, whereas grades sit on a 0 to 100 scale. So just be mindful of differences like that as well. Another point that we want to get into, and this is kind of a bigger picture thing, and we don't want to overwhelm people with too many details, but just thinking about conveying uncertainty. So data often contains uncertainty, and oftentimes unintentionally. So, thinking about the figures we showed earlier, that sometimes it looks like there might be a trend, but you're not explicitly going on to report that. You just want to be really clear to your audience what's happening in the data. It's not about errors that are happening intentionally, but just sort of unknowns about the data. And you don't want those to be misinterpreted by the audience. So always want to be mindful of including things like what percentage of students completed a survey or a task, what your sample size is for the data that you're reporting. If possible, include things like error bars or confidence intervals to show variability. Again, that's when you're kind of getting into reporting on some kind of statistic. It requires some knowledge of how to do that, but is a really useful way to showcase sort of that uncertainty in the data, the variability in the data. Also, if possible, to display the entire distribution of the data. So Natasha talked a little bit about that earlier. So instead of doing something like simply plotting a median or a mean for something like a Likert scale, showing exactly all the different scores that went into that response is really helpful to give people a sense of the variability in their responses. So this is just an example here of what error bars can look like, or confidence intervals. So just showcasing where the variability around the data is. Another thing to really be mindful of, and this kind of speaks back to that first point around noting what % of students complete the task or the survey or are represented in the data that you're showcasing, is that, for example, if any of you have conducted a survey in your classroom, something that we often help professors with doing, it's quite rare for every student to complete the survey. Or if you're doing multiple iterations, so you're looking at a pre-post comparison, it's not often the case that you get data from the same student repeatedly. So just being mindful of that, recognizing it, reporting it in however you're presenting your data in a report or in a presentation is just really important to give people a sense of who is being represented in this data, and how representative is that of the group that you're looking at. Okay, so next we're going to get into some best practices regarding considering color for scales. So quite a few of you brought up in that first figure that we showed that there were just way too many colors. They weren't distinguishable. It was hard to tell what was going on. And that's a common issue that comes up in figures. So This figure here that showcases a Likert scale, so looking at some responses from a strongly agree to strongly disagree scale, or on a scale. And so here there's sort of just this mix of colors. So you can see blue represents both strongly agree and strongly disagree. What we'd recommend instead is using a divergent scale or divergent colors. So this is where sort of the negatives are all sitting on one end and with one set of colors, and then the positives are sitting on another. So you're not mixing and matching those colors. It makes it easier for people to see where the trend is, and also to match the data between the legend and what's actually represented. This is a case where you're using a Likert scale, so it makes sense. You're going sort of from a positive to a negative, so it's divergent. If you're using something where it's continuous, using a sequential color can make more sense. So you're showing an increase in value, so going from lighter to darker helps to showcase this. There are cases where you want to use a mix of colors. This mostly makes sense in qualitative. So if you are looking at different groups and you want to highlight the difference between those groups, and that's what the focus of the figure is, then it might make sense to use different colors. So you're not wanting to show things on a scale necessarily, but more just different groups. The last point I want to talk about is best practices in considering color blindness. Again, thinking about issues around accessibility and making sure that people can perceive the colors that you're using, whatever those may be and in whatever circumstances those might be. This is an example here showing how different types of color blindness or color sensitivity can be perceived. So depending on the way that you might see this today, these look different to me, and they would be. This is how they would be perceived to someone with a different type of color blindness. So some things to consider when you're putting together a figure is doing something like switching your print screen view to grayscale, which helps you to see if you can actually distinguish the colors. So if you're looking at something like a Likert scale and you have two dark shades on your divergent end, so as something like strongly agree, strongly disagree, but then you switch it to grayscale, you might not actually be able to tell which one matches on which can be really problematic. So using that as a tool to really consider how others might view it and to make sure that it's accessible. Just another example of this here is sort of some do's and don'ts. So this is just adapted from a website where you can see that they're using labels to help indicate where which line on the line chart aligns with each. So again, for the purpose of reducing information, in that top figure, getting rid of the legend on the right side and adding it directly to the lines helps to make it clearer. And then on this bottom figure, there's a filter applied, so you can see if you look at the one on the bottom right, the pancakes and waffles look like they're the same color. You can't tell which one they are. If there wasn't that that dotted line, which is trying to help distinguish them, but in the same color, you can't tell the difference. So again, adding the label directly. If you wanted to add a legend, you could have something using a full line versus a dash line to indicate that that's what those labels are. But using the color alone is not really useful. And with that, we're at the end of our presentation. We do have some extra resources here just to showcase where the content was adapted from. Again, a few people in the chat had requests. We're happy to share the slides and the recording. It gets a little pre-processed from the events team, so happy for them to send an email to everyone with that information. But just wanted to highlight here some of these great resources that we pulled this data from that I think are just a really great starting point if you're wanting to dive into this a little bit more or get some more information. The Evergreen text actually walks you through how to make a lot of these visualizations. So they're what I used when I was trying to figure out something like a lollipop chart. Most of them were made in Excel, which is a pretty accessible resource or easy to dive into resource. And again, the Evergreen book walks you through step-by-step how to make them. So that wasn't the point of today's session, but just, if you want to, you say, okay, I need to make this change to my fingers, I don't know how. It's a really helpful tool, or a really helpful book. And then some more resources on making accessible visualizations. The second one I just have to point out is my favorite website. It helps you choose color schemes. You can indicate whether you're looking at divergent or sequential, the number of items that you have, and you can select a number of features. So looking at things like creating a printer-friendly or colorblind version, things like that. And with that, we have quite a bit of time left. We weren't sure how many questions we'd have along the way, so we wanted to give some room for people to have a conversation.